Unit 1, Random Variables. The following are the overall content of Unit 1. First section, Random Variable. Random variable. There are two types. One is discrete random variable and second one is continuous random variable. Second section, Moments. Moments. There are two types. One is central moment and second is raw moment. Third section, Expectation and Variance. Fourth section, Moment Generating Function. Fifth section, Chebyshev's inequality, and last section, Function of a random variable.
Definition of experiment: an operation or process which results in some well-defined outcome and generates a set of data is called an experiment. Next definition: random experiment: an experiment in which the outcome cannot be predicted with certainty is called a random experiment, even though all possible outcomes are known in advance. Example of random experiment: tossing a fair coin is a random experiment. The possible outcomes are head or tail, but we cannot say with certainty that head will come up. Similarly, the experiments of throwing a die or taking a card from a pack of cards are random experiments. Definition of trials: each performance of an experiment is called a trial. Example of trial: tossing a coin 6 times is 6 trials. Definition of sample space: the set of all possible outcomes of a random experiment is called its sample space and it is denoted by S. Example of sample space: I tossing a coin twice. Sample space S equals HH, TT, ETH, HT. A throwing a die once. Sample space S equals 1, 2, 3, 4, 5, 6. Introduction on random variable. In many random experiments, the outcomes may be numerical or non-numerical. For example, the outcomes when a die is thrown are numerical, whereas when we toss a coin, the outcomes are non-numerical. To deal with outcomes mathematically, we may assign numerical values to them. That is, we can assign a real number x to every element S of the sample space. Definition of random variable. A random variable is a rule that assigns a real number to each possible outcome of a random experiment. Or let S be the sample space associated with an experiment. A random variable x is a real-valued function defined on S, that is, x from S to R as a function for all S belongs to S. X of S equals x belongs to R. Example of random variable: tossing a coin twice. The sample space is S, H, H, HT, TH, TT. Let x is a random variable and denote the number of heads. Therefore x of TT equals 0, x of H equals 2, x of HT equals 1, x of TH equals 1. That is, x takes the values as 0, 1, 2. Range space: the set of all values taken by a random variable x is called its range space and is denoted by Rx. Thus Rx equals x of S/S belongs to S in the above example. The range space is Rx equals 0, 1, 2. Notation: if x is a real number and x is a random variable on S, we write x equals x for the event S belongs to S slash x of S equals x. That is P of x equals P of S belongs to S slash x of S equals x, for above example. P of x0 equals P of tt equals 1 by 4, P of x1 equals P of ht, th equals 1 by 2, P of x equals to equals P of h equals 1 by 4. Types of random variable. There are two types of random variables. One is discrete random variable and second is continuous random variable, discrete random variable. A random variable x is said to be discrete if it takes a finite number of values or countably infinite number of values. That is, our x is finite or countably infinite. Note: the sample space on which a discrete random variable x is defined need not be discrete. For example, if x is defined as the number of telephone calls to an office between 9 a.m. and 11 a.m., then it is finite. But the sample space S is the time interval 9, 11, which is continuous. Probability function or probability mass function. Let x be a discrete random variable which takes x1, x2, x3, etc. Let P of x xi equals P of xi equals pi be probability of xi. Then the function pi is called the probability mass function of x if the number P of xi satisfy the following conditions. Ip of xi greater than or equal to 0 for all I and E summation equals 1 to empty P of xi equals 1. The set of ordered pairs of numbers xi. P of xi is called the probability distribution of the random variable x. The probability distribution is usually displayed in the form of a table as given below. X equals xi takes value x1, x2, x3, etc. P of x xi takes value P of x1, P of x2, P of x3, etc. Note: if x1, x2, x3, etc. xi less than etc., then Ip of x of xi equals P of x x1 plus P of x equals x2 plus etc. plus P of x xi. Ep of x greater than xi equals 1 p x less than or equal to xi and 3 p of x greater than equals xi equals 1 p of x xi. Continuous random variable. A random variable x is said to be continuous if its range space Rx is an uncountable set of real numbers, i.e. the random variable assume values in an interval a, b, or in an union of intervals. Example: if x denotes the lifetime of a transistor, then x is continuous random variable. If x denotes the operating time between two failures of a machine, then x is a continuous random variable. Note: to define a continuous random variable, the sample space should be continuous. Probability density function. A function f, defined for all x belongs to infinity. Infinity is called the PDF of a continuous random variable x if if of x greater than or equal to 0 for all x belongs to infinity. Infinity. Integral infinity to infinity f of x dx equals 1. Note: Ip of x a equals integral infinity to f of x dx, p of x a equals integral a to infinity f of x dx. I p of a less than or equal to x less than or equal to b equals p of a x b equals integral a to b f of x dx. IV if b equals a, p of x equals integral a to a f of x dx equals 0. V for continuous random variable p of x less than or equal to a equals p of x a, p of x equals p of x less than or equal to a. P of a x less than or equal to b equals p of a less than or equal to x b equals p of a less than or equal to x less than or equal to b equals p of a x b. Cumulative distribution function or distribution function. If x is a random variable discrete or continuous, then the function f from R to 1 defined by f of x equals p of x less than or equal to x is called the cumulative distribution function of x. If x is a discrete random variable with values x1 less than x2 less than x3 etc. less than xi, then f of x equals summation over xi less than or equal to xp of xi. If x is a continuous random variable with PDF f of x defined for all x belongs to infinity, then f of x equals integral infinity to x f of x dx. Properties of distribution function. I0 less than or equal to fx less than or equal to 1. F of x is an increasing function of x. That is a less than b implies f of a less than f of b. F of infinity equals limit x to infinity f of x equals 0 and f of infinity equals limit x to infinity f of x equals 1. IV, if x is a continuous random variable, then df of x by dx f of x. Note: if x is discrete random variable with values x1 less than x2 less than x3 less than etc., then p of xi equals f of xi, f of x I1. If a less than b, then p of a less than x less than or equal to b equals f of b, f of a.